Hi gentlemen, have a great day. This is page number 181. Question: what is piping and pickup? Answer: this corresponds to the total amount of heat allowed apart from net load to provide for piping, pickup and contingencies. This is also arbitrary allowance to compensate for piping, pickup and contingencies in addition to the net load. Question: how much of the net boiler rating is maintained as piping and pickup allowance? Answer: Steel Boiler Institute as well as Mechanical Characters Association of America have established pickup and piping allowance. Mechanically fired boilers 33.33% of net boiler rating, hand fired boilers 50% of net boiler rating. Question: what is ECR and MCR of a boiler? ECR stands for Economic Continuous Rating, means it is the boiler load at which the boiler runs with optimum efficiency. MCR stands for Maximum Continuous Rating, means it is the maximum boiler load at which the boiler can run without any problem. Question: what is the value of ECR in terms of MCR? Answer: generally ECR of a boiler is 75% to 80% of its MCR. Question: in which case MCR or ECR the will boiler run with higher efficiency? Answer: ECR. Case study: boiler derating. A utility wants to retire its oil-fired D-type water tube boiler 1 megapascal 37.5 tons per hour temporarily. It needs a part of the steam capacity now for heating, but would like to drop down to a lower pressure, first to 0.3 megapascal, to be on the safety side with this piece of equipment which has same tube corrosion. However, the manufacturer advised against this as the reduced circulation might upset the heat distribution in the boiler, causing tube overheating and scaling. Boiler inspectors too advised the utility not to go for a pressure conversion. Nevertheless, the utility wants to derate the boiler down to 0.1 megapascal, whereupon it will no longer have to be concerned with inspection. Obviously, the volume of steam flow will increase. However, the utility thinks that its steam lines can handle the larger volume flow. It does not want to buy a new boiler capacity now for heating load in case this old boiler can be used. Question: what problems will the utility face in case they derate the boiler from 1 megapascal down to 0.1 megapascal? The boiler is a natural circulation type. Will forced circulation assist in this switchover? Answer: the oil-fired boiler, being a natural circulation water tube type, it supports well-defined water circulation path within the many parallel circuits of the tube. Since the driving force in such siphonic system comes from the relative difference in density of the working fluids between the warmer and cooler conditions of the boiler. It is this density difference that tends to work against circulation at low pressures. Circulation rate will obviously differ at 1.1 megapascal. At pump to assist circulation or an additional external downcomers would be impractical on the existing setup. If the operating pressure is lowered drastically, the following problems may arise. The steam volume will become so large that it may choke flow inside the tubes. Choking results in overheating of tubes, which may eventually fail. Even at 0.1 megapascal, sudden tube failure would be serious. The boiler will be more likely to prime. The superheater may give trouble also in a lowered pressure situation because the steam may not divide equally among the elements. The safety valve will need a much larger operating area to accommodate the larger volume of steam generated. With the same furnace volume and burner management system, a modulating or startup pattern may develop. The temperature exertion will tend to accelerate tube scaling and corrosion, especially with reduced circulation. Ability to take sudden load swings will be lower at zero point 0.1 megapascal than 1 megapascal. The most practical and economical solution will be operate the boiler at 1 megapascal coupled with a turbine that will act as a pressure reducing valve while lending itself as a prime mover for a fan, pump or compressor. Another sound alternative in case of the boiler is found or made reasonably sound is to operate the boiler at 7 to 8 megapascal and use the steam in heat exchanger to heat up the condensate going back to the boiler. Little makeup and water treatment is necessary. Question: what is the peak load of a boiler? Answer: it is the maximum load at which the boiler can run for a short period, normally a couple of hours, in a day's service without problems. Question: why has a provision been made for it? Answer: to accommodate a sudden increase in load demand over a brief period of time. Question: what is overloading of a boiler? It is running of a boiler at a load higher than its MCR value for a considerable length of time. Question: what do you mean by system load? Answer: it is the load power produced at any particular instant by all the plants of a power generating system. Question: what type of units are suitable for base load supply? Answer: large monoblock units operating on supercritical steam parameters usually supply a base load. Question: what type of units are suitable for semi-peak and peak load supply? Answer: subcritical pressure plants are particularly suitable for this duty. Question: why are subcritical pressure plants suitable for semi-peak and peak load supply? Answer: they are well suited for load variations. They have faster startup. They require less time to attain the installed load. Question: why are the monoblock units of supercritical pressure not designed to supply semi-peak and peak loads? Answer: these steam generation giants have large boilers and heavy metal pots. Therefore, they require a long time for a boiler firing and heating up of pipelines. They consume a greater amount of heat during startup, so it is uneconomical to resort to frequent startup and shutdown of these units. They are less convenient for control. Since they are high pressure boilers, their valves and fittings are prone to wear due to frequent load fluctuations and frequent startups. These high pressure boilers have thicker tubes that are more liable to develop high thermal stresses, causing corrosion fatigue, owing to frequent load variations. Question: what is the lower limit of load control range? Answer: operating experience has been established the following lower limits of the load control range. Fuel fired boiler type, lower limit of load control range. Fuel, oil, gas, high volatile coal is 40 to 45% of rated load. Lean coal, 50 to 60% of rated load. Slag bottom boiler, 60 to 75% of rated load. This is the lower limit of load control range. Next question: what is the lowest load for stable operation of a boiler? Answer: it is usually 30 to 40% of rated load. Question: why is advisable to select initial steam pressure equal to 13 meganewton per meter squared instead of 16 meganewton per meter squared for the operation of a steam turbine? Answer: it has been established from past experience that approximately the same economical efficiency characteristics are obtained irrespective of whether the initial steam pressure is 13 or 16 meganewton per meter squared. However, the manu- maneuverability of the power plants at this steam pressure is roughly the same. Past experience shows positive results in the operation of steam turbine plant at a pressure of 13 meganewton per meter squared. Hence, for a maneuvering power plant is advisable to select initial steam pressure equal to 13 meganewton per meter squared instead of 16 meganewton per meter squared. Question: for boiler plants operating at semi-peak and peak load conditions, the temperature of live and reheat steam is kept in the region of 530 to 535 degrees Celsius. Why? Answer: the tubes for boilers for semi-peak and peak load duty are made of pearlite steel. Pearlitic steel. For reliable operation under variable load, the temperature of live and reheat steam is kept at 530 to 530 degrees Celsius. Again, the tubes for boilers for semi-peak and peak load duty are made of pearlitic steel. For reliable operation under variable load, the temperature of live and reheat steam is kept at 530 to 530 degrees Celsius. Question: why are austenitic steels are not used to enable the tubes to operate higher temperatures? Answer: austenitic steels are much more expensive, 5 to 8 times, than pearlitic steels. If austenitic steels are used, it will greatly enhance the capital expander. Question: why is lower limit of superheated steam temperature kept at 480 to 500 degrees Celsius in a thermal power plant? Answer: this is to protect the final stages of turbine from erosion damage. These stages of turbine tend to be operate in the wet region of steam expanding through the blades of previous stages. Water particles sticking on the blade profile can cause impingement, corrosion or erosion. Thank you.